are live. So first off, thanks everyone for attending. Can still see attendees coming in right now. A few quick housekeeping before we start. During the call, please be frank with your feedback. Please do ask questions using the Q&A tab. The general format of the call will be each team will do a quick presentation on their part of the roadmap, followed by Q&A that's related to their product. For the Q&A, again, ask questions using the Q&A tab or raise your hand if you want to speak. Given the limited time, even though this is a 2-hour call, we probably still won't be able to answer every question or every piece of feedback on screen, but we will be logging everyone's comments and feedbacks. Also, please note that this call isn't necessarily going to problem solve every specific issue. We're hoping that any very specific things you guys can follow up on the developer community calls that happen regularly for each product team. And just so you know, the call is being recorded and is being broadcast on YouTube as well. So please be respectful when you disagree and when you give feedback. To start off the call, I'm going to pass the mic on to Maria. She's the Managing Director here at the Interchain Foundation.
Thank you, Saeed. Thank you, everybody, for joining us today, the community members and also the dev teams. I just want to go quickly on explaining on a very high level why are we doing this, and then share with you guys what should be the outcomes of the call and how we can frame the discussion today. So to start with the why, as everybody knows, the main focus of the ICF is the funding of the development of the Interchain Stack. And we do this working closely with independent developer teams. And but we need collaboration and coordination, not only among the ICF and the developer teams, we also need to collaborate and coordinate with the broader community. So, of course, having a roadmap as the one that we are going to discuss today is key in order to facilitate communication and the collaboration and coordination, because it really shows what is it that is going on, what is it that everybody is working on, and also it reveals the gaps and reveals the skills and resources that are needed in order to keep the Interchain Stack competitive. And it also creates a sense of collective responsibility. This is what we want, right? Like the Interchain Stack, the main responsibility is not only from the ICF or the dev teams, is a responsibility for the whole Interchain community. And so the idea is that having a roadmap is going to make it easier for developers, potential developers of the Interchain Stack and resource allocators to plug in and chime in with work or funding. And also is going to enable these developers and the builders, the users of the Interchain Stack, to influence the roadmaps. And by influencing the roadmaps, the community will be also influencing the resource allocation from the ICF, because we are going to base the decision on the allocation for 2024 on these roadmaps. So this is the first time that we are doing this. We are going to be improving this roadmap and these feedback processes. This initial roadmap is very focused on near-term goals for 2024, but we expect to expand this time horizon moving forward. So potentially these roadmaps are going to be multi-year, right? Because roadmaps are strategic plans, they are not work plans. The roadmap also, when the developer teams, they were building these roadmaps, they didn't have or they didn't limit those roadmaps to the funds of the ICF. The idea was that they were going to have in mind, or they were having in mind, the needs of the Interchain ecosystem and the needs of the Interchain stack in order to be competitive. What to expect after these initial calls? Please keep giving feedback. Feedback should be continuous. A roadmap is a living document. It's something that is going to be changing and it's going to be evolving with time. It's never a finished document. However, we do have an initial feedback window that goes up to September the 30th. And the reason we are doing this is because we want the developer teams to use this initial feedback to work on the first iteration of this roadmap. And is this, after this first iteration, is that we are going to, internally in the ICF, we are going to start working on the decision regarding the allocation of funds for 2024. So what are the outcomes of the call today? We hope that after this call is everybody is able to understand the roadmaps that are proposed by the teams and are going to be able to understand how these roadmaps are going to impact their projects on a high level. And also another outcome that we expect to receive after this call is like this initial feedback. You can be giving feedback here. After each presentation, there is going to be time for Q&A. One way of framing this discussion is thinking on a high level. You know, what are the things that you guys think that are missing from these roadmaps? And from your perspective, what are the highest priorities for the Interchain stack? What do you absolutely need next year for your product to be successful, or for the Interchain stack to be competitive? And what are your biggest worries about developing on the Interchain stack? And what do you think that you want to be different next year with your experience of building on the Interchain stack or any of its components, and what you want to stay the same? These are the type of questions that you should be asking the teams, and you should be sharing also with us. Okay, and this is it about the intro that I wanted to give. So I pass it to, let's start with the call. So I pass it to Adi.
Thanks, Maria, for the intro. So I'll jump directly into it with discussing about the CometBFT roadmap for 2024. This was prepared by the CometBFT core team at Informal Systems. I'll just give a couple of minutes of overview, and then I'll jump directly into the technical part of it. So to recall, CometBFT is the base layer of the Interchain stack. It provides replication. It's called State Machine Replication Engine, and it's fundamental for the well-functioning of the Interchain. As most of you know, how we do development, that happens directly on GitHub. We maintain also a documentation website. We are active on Discord. We're active on Twitter. And we maintain community calls that anyone can join, so please do so. So an overview of 2024, our mission is basically to grow the Interchain by making sure that CometBFT has a broader reach and applicability. We know that our users are application builders who seek to build sovereign and interoperable applications. The biggest user by far is Cosmos SDK, but there's also non-Cosmos SDK numerous users. And what we believe that will help a lot is that in the future, applications that build on CometBFT, they will prosper by differentiating themselves increasingly. So we believe that increasingly higher quality services will be built over time that are more and more differentiated. And this means that CometBFT, as well as all the other public goods, they will need to reach new levels of flexibility and modularity. In terms of the technical background and history of this piece of infrastructure, CometBFT is a successor to Tendermint Core, something that we all love and we all cared for many years. We launched it, however, in February as a fork of Tendermint Core because that stopped being maintained. At that point, it was version 34. A month later, we launched 37, and a week ago, we launched CometBFT 38, which was the final phase of ABCI++, which has been in preparation for roughly 2 years. Multiple teams have worked on it, a lot of external contributors, so it's difficult to understate the importance of V038 for the health and the development of the interchain. Throughout the rest of this year, so in preparation of the 2024 roadmap, we're going to release V039, which is already under preparation. And many of the things that go into 39, you will see that they will also reflect throughout 2024. That includes bandwidth and storage consumption, it includes improvements to the API, RPC layers, versioning of RPC and protofiles, and so on. The final context that I will give is that we expect that with the beginning of 2024, 38 has seen adoption. We optimistically hope that it will be adopted in tens of chains. So usually adoption cycle is pretty slow for Comet and the SDK. So we see innovation, we expect to see innovations on top of ABCI++, but we also expect to need to support novel protocol designs and to provide support in the form of workshops, as we plan to do at Cosmoverse, which will happen in less than a month, something that we're all looking forward to. And that's going to happen in collaboration with the SDK. Cool. So to jump into the technical part, I'll first start with the strategy. And by strategy, we simply mean what do we want to enable? We want to enable more use cases, first of all. So we want builders to be able to address a wider range of use cases. Second, we want that operators, node operators, validators, relay operators, and so on, they are able to have more affordable infrastructure in the running of their nodes. Third, we expect to do an order of magnitude simplification of how IBC can be built, run, and maintained by simply allowing IBC to be kind of under any programming language or framework. This is a pretty interesting one that we will get into. Fourth, we want more peace of mind, both for the core Comet developers and for builders on top of Comet. This is also very important because multiple teams have been burned out by trying to maintain Comet. It's not an easy piece of the stack. It is an extremely complex and old software. That's why this has an explicit goal here, even though it may look like addressing technical debt or something unexciting like maintenance. It is not that. It is a bit more important than that. And last of all, user experience improvements. We want to allow users to easily build CometBFT-based applications to run and maintain CometBFT-based nodes. So this is a more broader and more broader scoped team. In terms of the specific sub-projects that we will pursue towards enabling these 5 strategic teams, they are as follows. Something that does not have a priority assigned in terms of peace of mind is the ongoing maintenance of the software. So this is something that we will do throughout the whole year. We are prioritizing always being responsive on Slack, on Discord, in GitHub, maintaining regular community calls. So this is extremely important, in particular because Comet is such a foundational layer of the stack. If security is a problem, then it is often impacted, or it is often coming from the Comet BFT layer. The second sub-project, we gave it the idea of bandwidth. In this case, this is roughly speaking our first priority as a sub-project, and what we're going to look after is targeted bandwidth optimizations. In terms of outcomes, this will have impact on use cases, so it will enable more use cases, and it will also make it more efficient for operators to run their nodes. And this has two relevant contexts attached to it. First, we are aware how vote extensions that we delivered in Node 38, they bring about a higher bandwidth consumption, which can in turn result in a lower throughput of the network. So in order to mitigate the impact of that and to at the same time facilitate greater adoption, we're going to look at reducing bandwidth consumption throughout the different subprotocols of CometBFT. Second of all, we are also aware that nodes that run that gossip a bit too much, if that gossip happens via inter data center links, that can cost a lot for operators. Then we have storage sub-project. This is very similar to the bandwidth one, except now we're not going to look at the bandwidth front. We're going to look at the data footprint. This has in additional beside use cases and efficiency. It also addresses a user experience concern. And in this case, we're going to try to figure out reductions in the different backends, pruning and indexing, which we already started, and some of those will land in 039. And the overall impact is that this will drive the costs of operators lower. Modularity, something that will be a recurring theme, not only at Comet, but SDK and IBC as well. The primary thing that modularity achieves is a broader use cases. Like we said, we want the software to be flexible and modular because builders are building highly specialized and increasingly more differentiated services. So this is very important. In particular, we're going to start in 2024. We're looking at modularity for the consensus subsystem of Comet because this is at the center of it all. And if we are able to do that properly, then we are able to do many other things. So this is one of the reasons why we start from there. It is based on several notes of feedback from users who expressed that they would like in a year or so to be able to replace the consensus engine, but also more broadly than that, they would like to replace certain components like the mempool, like the way gossip happens, and so on. IBC, this subproject, we call it XIBC. It is about doing a feasibility study to see how we could provide IBC support directly in the consensus engine. It is by far the riskiest subproject in which we will engage. It's something that actually core teams rarely do. So we approach it with a lot of cautiousness. It's not something that we're going to say we will deliver. It is something that we will definitely be scoping, exploring, de-risking, and validating. And it will also imply changes to ABCI layer. It's something that we're actually looking forward to, not only from the point of view of IBC enabling, but also from other changes, which we will talk about in a second. But basically, we will be looking at changes to the ABCI layer because of this correctness. This is to address peace of mind, both for core developers and users. We're going to look at several core protocols and how we can increase the confidence in their correctness. Some of the things that we already did and which we will continue, these are important because otherwise we're not able to progressively rewrite CometBFT. We're not able to move from this current state in which the code base finds itself. And the outputs here include formal specification of core protocols. We might be do MBT, model-based tests, implementations of the core protocols as well. Something a bit in the same vein as correctness, we're gonna expand the stress testing. This was one of the most important things we did at the end of 2022 and at the beginning of 2023. It allowed us to ship 37 and 38 with peace of mind. And it was by far one of the most important things that we spent our time with. And we're going to try to continue doing that. For instance, we did some very small experiments already this year with local prototyping and local testing. This is about more stress testing, but being able to lower the barrier at how we test the system is also very important. Next one is same block execution. One particular team that we are aware might need this or will likely need this is Celestia, but there's also other teams. Oasis Network have also voiced some requirements in this direction. This is so that we address some of the problems that occur with programming with CometBFT or Tendermint. Actually, it is the fact that proofs from the current block, they only become available in the subsequent block. It can lead to off by one errors and so on. There's a lot of context here. People have been looking into it before. We only have 3 left, so we're almost there. APCI peer-to-peer. I think this is actually an idea that came from the SDK, and some core developers of Comet have also been thinking about this. we're going to try to allow application builders essentially to access the peer-to-peer layer directly. Via ABCI, currently they're unable to do that. So all you can do at the peer-to-peer layer is essentially broadcast TX. And we're going to try to broaden that. Something very important, but that rarely gets enough attention is documentation overhaul. In this case, the impact will be with user experience, and we're going to provide specifically better onboarding and reference materials for the different categories of users. We know that the users of CometBFT are very broad. There's 5 categories, and we're going to look at how we can address at least the first 3 categories, most important ones. Currently, this doesn't even exist in any shape. The documentation material is not customized to the user. And finally, this is also a single binary sync from Genesis. This also comes as a requirement from specific teams, some of them being Celestia, though we also heard from other teams. It will have impact in efficiency because it's going to be a lot faster to sync a node, but it also has UX implications. And essentially what this is about is the ability for CometBFT networks to synchronize from the Genesis with a single binary, and this is not currently possible. And with that, I'll stop here. The rest of the document provides some rationale. Why does the table look like this? And we also provide some positioning and some of our thoughts beyond 2024. So we hope that the rest of the document will also be insightful, but I don't think it's probably a good use of everyone's time to look at that together. So I'll be glad now to take any questions.
Thank you to everyone who's been writing in questions, and thanks to the people answering them. But yes, if anyone would like to speak and ask Adi a question directly, please do raise your hand. All right, we have a question. Sardar, you should be.
Oh, yeah.
Yeah.
Can you hear me?
Yeah.
Yeah.
Okay, I was just going to ask, you talked about the peer-to-peer layer, potentially getting more like you could access it through the SDK or other parts of the CometBFT, but what kind of use cases would peer-to-peer access enable, basically?
The general trend that we see is that the application builders are getting more and more confident, and they want more power and control over the network specifics. For instance, they would be able, if they were to have direct access to peer-to-peer, they would be able to construct blocks themselves. They would be able to disseminate entire blocks without any ordering guarantees. And then CometBFT and ABCI would solely be used to apply an ordering over those blocks that the application constructs. So you can imagine a use case where the application constructs something like 5, 10, 20 blocks, and they're all pending, they're all in flight. The network is disseminating them because the application has direct access to peer-to-peer. And then they would be using basically deliver finalized block or deliver PX to get an ordering over those blocks. So it allows essentially, this is just one example, but there's other stuff. You could also broadcast non-consensus related stuff, like you can just broadcast the application can just broadcast unordered data that only has best effort guarantees, but it will still, and it doesn't need to ever go into a block. So Comet could have this dual use case of both ordering and, more broadly speaking, broadcasting of data. So those are some examples.
All right, thank you. If there is nothing else specific to CometBFT, we'll move on to, oh, sorry, we do have.
I have one quick comment, Saeed. Adi, I saw that at scale testing is on the list there. Strangelove's built some stuff for that might be usable by the Comet team. And in fact, we've designed it specifically for Comet. So if you're interested, we'd love to partner with you on that.
What is the name of that?
It's called VRT. It enables spinning up large Comet clusters across many different clouds, but arbitrarily sized clusters with arbitrary genesis manipulations, all the fun stuff you would want.
Cool. Yeah, that sounds quite relevant. Let's look into it. Thanks.
All right. I think we have one more question for Comet from Robert.
Hey everyone, and thanks, Adi, for the presentation and the overview of the document. I'm a little bit puzzled about like what it would mean for CometBFT to support, let's say, Avalanche and other protocols. So like technically, okay, you can say that it's CometBFT a network layer. I mean, you talked about like a modularity, right? I know that Avalanche already also works on supporting IBC, I think, ABCI stack. So like to able to run Cosmos apps directly in Avalanche protocol. Yeah, and then like what's the vision of CometBFT? Like if it's not basically a consensus protocol plus network layer.
So I think you touched on two things. You touched both on Comet plus Avalanche, and then you also touched on Avalanche plus IBC. With respect to the first element, Comet is both
Avalanche plus ABCI.
I see. Thanks for clarifying that. Yeah, this is a pretty important question because Comet is currently only supporting the Tendermint consensus algorithm, but there's others. Avalanche is a pretty complex consensus algorithm, and it's also a framework itself. So we could imagine. By the way, I didn't say anything in the roadmap about Avalanche, so I'm not sure where the question is, but I'll still try to.
It was in the chat somewhere.
Okay. So I don't think we plan on looking into Avalanche. None of the members of the Comet team spoke about it, to my knowledge. It is possible that builders from other organizations will adopt CometBFT, and then they will have specific requirements of what is the consensus algorithm that runs with CometBFT. Generally, the appeal of CometBFT is not necessarily Tendermint consensus algorithm, though it is one of the appeals, but it's not the only. So we know about some teams that are looking into adopting Comet, but they're not super excited about Tendermint consensus algorithm. And it could be that Avalanche is one of those teams. I'm not aware of it, so I'm just speculating. So if it is the case, then what they would like to do is to adopt the framework Comet or the replication engine Comet, but with a twist, which is that they wouldn't like the deterministic Tendermint consensus algorithm, that they would like something probabilistic along the lines of Avalanche or something else. That's what I can provide there. All
right. So to just like summarize it, the vision of CometBFT is to be like the modular stack or like a SDK for not the app, but SDK for network plus consensus.
Yeah, that's actually a very nice way to phrase it. Thanks for putting it that way. Like I said, what is driving us is allowing application builders higher and higher power and control over the network, because applications are getting more sophisticated and specialized. It is actually very impressive what we see from application builders. Is driving us into making these modularity efforts to essentially allow pretty much all of the core components of Comet to be replaced with either more advanced things that already exist, more efficient things, higher performance, and so on.
That's very challenging.
Cool. All right, so if there's nothing else for Comet, we'll move on to CosmWasm.
Okay, that will be me, I guess. Let me share my screen quickly. Let me talk a little bit shorter, but I would like to cover our important points in our 2024 roadmap. The first point in our roadmap is basically what we do all the time. As a Confio, we develop and maintain the software stack for running most smart contracts on Cosmos chain. Like it is used by so many big chains like Osmosis, Juno, like Mass, Noise, and so many chains applications. So it's already basically the core of the Cosmos ecosystem at this point. And our main focus is to maintain Cosmos VM, to maintain Cosmos Tut, multitest for testing contracts, what's the storage plus, and all those create libraries around, also those smaller ones which we had to fork because they were not usable in WASM environment. Maintenance is mostly bug fixing and addressing issues which are popping up on our GitHub, but also we are aware that we lack documentation, and right now I'm talking mostly about technical documentation like doc.rs documentation for crates. So this is something we want to also focus on improve, together with improving the test coverage of all these crates we are talking about. This year, we would like to include the Sylvia framework as part of our core stack. We hope to release the stable 1.0 version 2023. So 2024 would be the year when it would be already in the maintenance phase. So yeah, it's the framework was well received by the community. It is used by big projects like Mesh Security. It's basically built entirely in Sylvia, but this is not the only project I am aware which is using the framework. So yeah, that's like our first main point. But then there is also zero knowledge proofs verification. We would like to bring zero knowledge into the core Cosmos, the core of Cosmos, the library and the VM. Right now, we don't have API shaped. We didn't do proper research. We just know we want to go that direction. So the 2024 would probably not be the final year for this particular point, but this is the year when we actually start the research, which cures are relevant to support, and we need to define the proper API. We would like to provide the examples of usage of this API, and we also want to keep it performant and keep the gas prices low. So we would benchmark our solution all the time to keep the footprint low of this zero knowledge proofs primitives, right? Okay, so this is another important point for us for upcoming year. IBC, which is basically one of the most relevant things in Cosmos ecosystem right now. There are IBC features which we are aware at this point that are important for upcoming year, which we want to incorporate into the Cosmos ecosystem. The part three, which I am aware of, is AD rate at this point, IBC fees, and optional and delayed acknowledge messages. And yeah, that may be a case that there will be new IBC issues which would come up during the year, which we would also most likely to focus to implement. Another thing which is more the UX thing, but not only, is the storage. Like storage plus crate is pretty forgotten crate, which is used in every single smart contract I ever worked with, but it was not updated for a long time, at least with like significant changes. So we would like to make some changes, not only in storage plus, but in the general in the storage in Cosmos. First of all, we would like to redesign the key layout. The reason for that is basically make them more compact, smaller, so we can use less storage for them. And basically, the same reasoning is about the binary coding data right now, and the data like stored in Cosmos is encoded in JSONs. They are nice because they are easy to read. You can analyze them, like basically dumping the data, but they are costly. They are basically big. That's the text encoding. We would like to lead towards some binary encoded formats like protobuf, for example, or Symbol. And also, we would like to make some API improvements, which I mentioned. So Storage Plus is kind of aged crate. We would like to either provide some other solution or maybe improve what we have already. But in general, we would work on API improvements in terms of storage access. Another point, oaths and free grant, and there are a couple points, but I think that two most important are implementing message grant, message exec, and message revoke as first-class citizens for contracts, and possibility for querying grants from the contract level. Another things we would like to do here is create some example application to show how to use all those things, and in general improve usability of oaths and free grant with CosmWasm. And besides that, there are some other things which are either smaller or difficult to categorize. First of all, we would like to improve IBC adoption. And for that, the first step is to provide the proper IBC application. To be a good example on good patterns on how to use IBC from the Cosmos. IBC is already used by Cosmos application. Like I believe that noise is using it heavily. Like the whole mesh security is built on IBC in smart contracts, but we need a proper, simple example for developers. Also, this year we organized the CosmWasm conference, and that was a great success. In our opinion, we would like to continue that, but we will not have the second edition this year, most likely, or next year, most likely. We are preparing ourselves for possibility to run the second edition of CosmWasm 2025. What else is I mentioned before, the documentation, in particular documentation, technical documentation like docs.rs documentation for our crates. However, it's also important to provide some documentation for full stack DApp builders, as our users are not only like purely smart contract developers, but also people who would like to read smart contracts to provide to build frontend on top of them, and in general build the apps with Cosmos. And finally, we are considering running the testnet with for the pure CosmWasm chain agnostic Cosmos contracts. We had those in the past. There was the Malaga testnet, there was some testnets in the past. Right now, there is no such testnet I am aware of. So we are considering ways to provide this kind of utility and maintain it, so people can test chain agnostic chains on the testnet. Okay, so this is our roadmap in the nutshell. Are there any questions about it?
I just answered one question from the chat, which was about error propagation in contract-to-contract error cases. This has been a pain point for a while. To me, this falls under the maintenance category. Those are those smaller and mid-sized feature requests that are coming up. This is something that we have scheduled for CosmWasm 2.0, which we want to ship this year. So it's not part of, or at least not explicitly part of the roadmap.
We have a question from Robert. Robert, you should be able to speak.
Yeah, hey, thanks. CosmWasm 2 was in the presentation. That's the conference, or that's something else?
Yeah, that's the conference. We had it 2 months ago.
Right, yes. So yeah, basically my question is about like what's the CosmWasm 2? What, I mean, Simon, you just mentioned it.
The new version of Cosmos library, basically the Cosmos 2.0, I assume. I mean, sorry, Simon.
Yeah, but my question is rather like why it's 2.0, so what's breaking and what are the highlights?
Yeah, so I gave a presentation at CosmWasm about CosmWasm 2.0, but I tried to summarize it in 20 seconds. It's a compile time breaking upgrade that ensures that CosmWasm 1.1 and CosmWasm 2.0 contracts continue to run side by side on the same chains. It improves a lot of APIs and polishes a lot of changes, polishes a lot of things that we did wrong when we designed those things the first time almost 2 years ago. And in a number of places, it already also unlocks new features and possibilities. But I will look up the presentation and send that to you, because that goes into way more detail about what CosmWasm 2.0 is.
Awesome, thanks. Could you send in the chat or directly on the Slack? Yeah, and the second thing I wanted, thank you. Yeah, and the second thing I just want to comment. A year ago, I started like hacking on the Storage Plus to use a binary format. I did like a few improvements this year. I didn't publish it yet. It's like on my local uncommitted store. If you want, guys, I can like try to find time, maybe like around the Cosmoverse. Not sure.
Yeah, would be appreciating if to see what you got, to see what the demands are and what ideas you have for this.
Yeah, it's basically like a more limited version. And also like about the comment about protobuf, I don't think a protobuf is a good idea for Storage Plus, yes, because like you need to compile the types.
I fully agree. I think a point of the roadmap action item is there figure out the best way and not so much commit to this or that solution.
Yeah, so I'm using Bosch because it's battle tested already. Yeah, in year.
Yeah.
Cool. I think we have questions from the panelists. Susanna?
Yeah, I was just wondering what an optional IBC acknowledgement is.
That is, if a contract receives an IBC packet to the contract, and right now it has to send an acknowledgement as part of the return type of the processing of that of that packet in the same transaction, in the same call to the contract. However, that is not always what you want. Sometimes you want to delay writing an acknowledgement across transactions, maybe across blocks, and write the acknowledgement later, which came up for 2 use cases. And one is Larry trying to implement packet forward middleware in CosmWasm. And the other use case is long polling for interchain queries, such that I send an interchain query, but the moment the query request is received, the response is not yet there. So it might take a few blocks. Then when the response is being available from the application, then a few blocks later, it can create the acknowledgement for the packet and then send it back.
Okay, cool. Thank you. So it's more like asynchronous than I just wanted to make sure it's not deleting it altogether, because that would be problematic.
No. It's more like getting from the contract perspective more flexibility at which point in time the acknowledgement is written.
Okay, thank you.
Another one from the panelists, Jack. You're muted.
Which particular question?
Oh no, you had your hand up. I thought you had a question. Never mind.
I'm sorry. I think I was clicking through the chat and the other things and I accidentally raised my hand. Sorry about that.
It's all right. We have another one from the audience. Sardar, you should be able to speak now.
Yeah, you can hear me, right?
Yeah.
Yeah, I guess I had a couple questions, but the first one is because this came up in also some of the features that we are developing as well. But is there any work on like allowing contracts to pay for fees directly, not necessarily IBC fees, but like transaction fees? Or is this something that you'd be interested in putting on the roadmap or something?
I think part of that is IBC fees. The other part of it is fee grants. So a contract can give out a grant to some external contract, some external address, and say, yeah, use my fees instead of paying the fees on your own. This is really the functionality available in the Cosmos SDK already that needs to become accessible in CosmWasm, and this is what we want to do. We had this use case quite a lot for onboarding experience when you have a decentralized application and some new user, and you want a contract that pays for the fees of a user that is then limited to one particular contract and maybe only to some certain functionality within that contract. So it falls in this bucket, I guess.
Yeah, thank you for that. Yeah, I guess another thing is there's also, I think, some work done about the storage you were mentioning in some networks as well. Like I think Secret Network has like modular like storage, so you could like switch the type of storage you're using, like you can switch the bin code to versus something else. So it could also be interesting to like make the storage modular in the sense of like which encoding you use.
Yeah, I think that this kind of stuff is something we may consider. We don't have particular list of APIs or of we as Simon said, we didn't yet found which binary protocol we find the best for our storage. So right now we just see that there are issues, for example, that that storage items get too big, they could be compressed. And I think that this is the thing to consider, the thing to like carefully design. Like now Storage Plus was basically created to allow you access to storage, which was, you know, key value pair. It was not very intuitive, so we needed to have the proper user-friendly layer, and we needed it quickly. So it was created there without like deep design. Right now we have time to redesign it slowly, and we can consider this kind of addition, like you see, as you said, the custom serialization and so on. Right?
And regarding modularity, it's already the case that those things are modular because a CosmWasm contract has raw key value access to its substore on the database, and it can use whatever storage layout it wants. It's just a matter of, okay, what are the solutions that we provide as best practice that can live alongside more advanced solutions that might only be usable or only be good in very specific cases. Maybe the functionality is limited or has different trade-offs than the current default implementation. Another point regarding secret network, I think a big difference there is that they don't support iterators, which is an amazing feature in the Cosmos stack, being able to iterate over storage that we heavily rely and use. The solutions that we provide make the use of iterators very convenient.
Yes, thank you so much. And I'm very familiar with the iterator problem because I did work on secret network for a while, and I wrote their storage kit, and it was, we had to recreate the iterator in CosmWasm rather than in from the SDK.
If there's no other questions for CosmWasm, we'll move on to Cosmos SDK. And Marco will be speaking about their roadmap.
Awesome, thank you. I'm going to share my screen if I find the right screen. There. Oh, which screen do you guys see?
A blank one.
Nothing yet.
Yeah.
Now?
Yeah, good.
Okay, no, you see. Okay. Thanks everyone for joining. Thank you for the Confio team and the Comet team for giving a nice overview of the 2024 roadmap and beyond. Now I'm going to talk a bit about the Cosmos SDK. So I don't feel like I need to give an introduction. I feel like we all kind of have an idea of what the Cosmos SDK is and what it does, but not really where it's going. So in this talk, I'm going to briefly touch on the technical debt, modularity, maintenance, and our future, some ideas for our future, and some ideas then in research areas we want to go. So starting out with the core layer. So the core layer is what we define as everything below the module. There's a lot of technical debt there. If you've read the base app code, you've probably hit your head in a wall a few times and asked, how does this work? Well, we want to clean that up. We want to make it modular, and we want to abstract consensus. What does that mean? It means that we want to allow users to be able to work with different consensus engines, i.e. Robert was mentioning something about the ABCI apps and Avalanche, make that more seamless. Users with Rollkit, make that more seamless. And really plugging into the modularity. And this leads into the next part of the core layer. So at the modularity layer, we want to allow people to plug in different mempools, plug in different servers, plug in different consensus engine. And this really dives into really making the Cosmos SDK an SDK and not a framework. We want to be a toolkit to build a blockchain. We don't want to tell you how to build a blockchain. Now, when it comes to the modules, there's a different story there. But before that, just diving into some storage and performance. I'll keep the Q&A open. And so if anyone asks a question while I'm talking, then I'll make sure to answer it. So on the storage and performance. So within storage, we've, in the Eden release, we've done a large refactor of the node key design. This is actually very similar to, if you've read the blog post from Geth 113, we've actually had a somewhat similar refactor around the same time, interestingly. And so a lot of the future of the users who are using 0.50 and beyond will have better performance. But okay, so we're not really going to stop there. We're already starting on rewriting storage. And what does that mean? We want to have scalable clients. We want people to be able to query nodes, submit transactions, at a rate that's higher than today, we want to compare ourselves to really these Web 2 speeds. Like if we play around with the Web 3 JSON RPC, gRPC endpoints, we're not really hitting close to what a normal REST API or a normal JSON RPC API can do in the Web 2 world. And so we really want to compare ourselves to how Web 2 is doing it and those speeds. Secondly, we want to have better external DB support. What does this mean? This means that right now in the node, we're having a lot of people add secondary indexes, add things that are making clients' lives easier, but it's actually the state of the state machine. And many times these secondary, third, fourth indexes are not actually used by the state machine. We want to keep the state machine very lean. And so we want to make it easier to stream all the state updates out to different databases. This is already supported, but it's kind of like it's supported, but it doesn't have the tooling there. You need to build all the tooling yourself. And we've gone through the endeavor of building a lot of this tooling, and we want to be able to like provide it to the ecosystem. Smaller disk space, we love not having to pay those huge database costs. Shout out to Evmos. And so we want to make the databases smaller. We want to make it more efficient to be able to use the database that we have. Now, in the modularity section, a lot of this refactor that we're doing right now and will bleed into 2024, especially with the audits that we plan on doing, is we won't be able to swap commitment structures. This means that users of Rollkit is to be able to have smaller fraud-proof sizes, witness-proof sizes. They want to be able to use SMT because IBL has certain properties that expands the proof size. So for stuff like this, we want to be able to more seamlessly swap commitment structures. But now, once you swap the commitment structure, now you want to use IBC. IBC is an ICS 23, is currently tightly coupled to IBL. You can use it with other stuff. The IBC Go team is working on expanding it to things like SMT. But what if there's a world that you can use the Cosmos SDK, you can have all your modules sit in a different commitment structure, except IBC, it can live in IBL. And this really enables a future where if a chain wants to migrate to a different commitment structure for different purposes, then they'll be able to leave IBC as it is today and not have to worry about migrating over and doing a whole chain breakage for not only for themselves, but for people that they're connected to. So modules. So what's the technical debt on modules? Now, all of us there's a bunch of issues in the Cosmos SDK complaining about this module doesn't do this module doesn't do that. We want this module to do that. And the modules, in the most case, were written close to 4 years ago. We want to rewrite it. We want to make them more seamless. We want to make it easily provable in VMs. This means that we want to reduce the amount of code, reduce the amount of computation. So when we go to prove it in different VMs, it's a lot harder to recreate. Less lines of code, and we want to write the modules in a modular way. Now, we've been with the new accounts module that we're writing right now, there's been an adoption of plugin based business logic. And what does this mean? It means that we provide a foundation, and then you as the user can just plug in this certain business logic that you want. So you can use a CosmWasm smart account, you can use a native Go smart account, you can use an EVM based smart account. And this really says like, hey, we'll provide the foundation and you just plug in whatever you want. And so the idea is like, should we go in that direction, or should we just make it easier to fork, make the code easier to read? Some example of like a staking module in the plugin based business logic would be something like, we provide a Valset manager module, and then you just plug in a delegated proof of stake business logic or proof of authority business logic. And so you only have to deal with that logic. You don't have to worry about returning the Valset updates and everything like that to the underlying consensus engine. And so we're really diving in and thinking about what to do there. So now I believe if Juan from Zondax is present, he'll give a short presentation on the cryptography in the Cosmos SDK, but in the wider Interchain stack and what they have in mind for that.
Thank you, Marco, for the invitation. Let me see if I can share some slides. So basically, this is a kind of like quick overview on kind of like some additional changes that we would like to propose for the SDK. I mean, for some context, As you can see, the theme is towards modularization in the whole stack. There have been some ADRs with respect to that, and at the same time, there are like a lot of open issues and requests on the SDK for kind of like some points that require some changes, some substantial changes for those to get solved, mostly related to cryptography. And what we have seen on top of this is that ADRs today minimally address like these points like cryptography, HSMs, KMS. So this is something, I mean, there are a few that are listed here, but it's something that it seems that has been like kind of like collecting technical debt over time. And this is something that we want to kind of like address in the next year. So in general, like our goals or what we have planned for this is obviously, as I said, like in model design, like we need to be sure that there is a smooth transition. So we need to provide a proper migration path and be sure that backward compatibility is always considered. But the main point is to find some extensibility points. So projects that they want to address different kind of like innovations, or they want to kind of like extend or use different curves or different things, they can do that. I will go through those like a bit later. And obviously any kind of refactoring or modification needs to be kind of like supported by some quality assurance work. And this is something that we think is going to be kind of like critical too, particularly like improving test coverage, robustness, and running some audits on this. Moreover, as you will see, there has been some requests in the past for having some kind of like a, not just pure extensibility, but some kind of like plugins to extend the cryptography of the SDK with remote or kind of like external signers. So we want to kind of think of that, because typically developing plugins is kind of tough, and if you don't have the proper tooling, so address that. And obviously community engagement and dev experience is something that I think it will be important, more when we have all the things that Marco was discussing about, like rewriting and doing these big changes. Technical objectives, I mean, there are a few more things, but the key aspects are generalized support for hardware devices and external signers like cloud-based KMSs, be able to support things like Ledger, YubiKey, Thales, Azure, AWS, PKCS 11, TPM, and other things that, I mean, the thing is, at the moment, even adding a simple curve to the SDK has been like really hard. It's like pub keys and private keys are spread all over the SDK in different ways. And what we want to be able is to let people extend and add new cryptography improvements in the ecosystem or innovation, and be able to do that without like having to fork. That's one of the main things we want to ensure, that you can leave and extend the SDK without having to kind of like go on your own. Last but also very important is that we know that some teams, they have, I mean, we have been trying to connect to many, and some teams are looking for, I don't know, things like PLS, starting to see how they can introduce like zero knowledge, how they can have like other curves, how they can like look at maybe RSA or threshold schemes. So we want to somehow address all these at the interface level. So extensibility is key. As a high level concept, I mean, we've seen that at the moment there had been like a kind of maybe too much coupling between like wallet related or blockchain related code that addresses like how you can address or how you can encode an address to what is actually pure cryptography. So we want to kind of like divide this in a few layers. We are going to prepare an ADR and publish that. I mean, we are working on that ADR internally, but to have separation between like what is like blockchain specific that is related to wallet management, addresses, encoding, like vanities, things like that. Then we have a kind of like clear store that key store that has to be extensible. So you don't have to only have that like locally, but you can rely on external tooling. And inspired by PKCS 11, which is a good thing, but also a bit of a node monster. But the inspiration is kind of really useful. We want to kind of introduce the concept of crypto providers, that they allow some kind of level of abstraction on how to deal with keys and different schemes. So crypto provider, the idea is that it's at the interface level. I mean, I'm trying to keep it not technical here, but it's a way to kind of like separate the concept of generation, derivation, time, verification, and encryption. So we have these things, and depending on the scheme and the hardware, you can, for example, be able to say that there is a hardware device that can sign, but it cannot generate, as that would be a ledger device. or there are like some devices that you can like, I don't know, maybe sign, but verification is too expensive because you are running that on AWS. So we want to kind of like decouple these different providers. They can be written by the community and they can be introduced into the SDK via dependency injection or external plugin infrastructure that can be extensible. So in the end, it's like if someone eventually wants to use the, I don't know, gRPC, or someone wants to use something else, this is kind of like irrelevant to the SDK and you can extend the way you want. So, I mean, kind of like we want to divide these into kind of phases. One is like design, ADR, proof of concept, modularization, and refactoring. So we introduce the interfaces and later we start to work on implementing some of these things. The idea is that we don't want breaking changes, but we want to provide the community like a upgrade path where they can still use what it was there before, but they will, I mean, hopefully they will see all the advantages of the new structure to move over. And this is kind of like super quick, but yeah, I go back to Marco for kind of the continuation. And if you have any questions, of course, you can ask us here, or you can contact us in Slack or the other channel. Thank you.
Awesome.
There is an open question from Jesse. I'm not sure if this is for you, Marco, or for Juan.
I think this one can be given to Marco, actually. It's relevant.
Generally, security audits should not be positioned as only security treatment and higher risks. To work on cryptography and to refactor significant portions of the Cosmos SDK is somewhat risky. How will your team be addressing the application security throughout its 2024 development cycle? This is critical for being able to trust upcoming releases. Thank you, Jesse. I believe this is Jesse from Amulet. She's spearheading the security for the ICF. So you've been most likely seeing some tweets from her. Huge shout out to Jesse. She's doing an amazing job, and her team. But yes, so we do want to, it's less so like, I use the term like continuous audits, but it's not really a continuous audit system. We want to be able to work with auditors that understand the code, and every time we go to an audit, they don't have to onboard onto the code. And that's kind of like what I mean by when I talk about like continuous audits. We want to we're able to work with a few auditors that understand the code, that we will be going through audits through almost every layer of the code base as they come out. And so we want to be able to first provide better testing, provability. We want to be able to do audits with teams with auditors in timely fashion in order to be able to facilitate quicker releases. And so we kind of see that as helping identify that, helping bridge that gap to what we have today. Does that help answer some of the question? I think we still have to like work out a lot of the security stuff and who the security audit teams will be. I've talked to many of them, gotten quotes from many of them, and it's just a matter of deciding on which ones we want to be able to move forward with in order to begin the kind of onboarding onto the code base. So when we do audits in the future, there's no need for them to spend 3 days onboarding onto the code base in order to be able to facilitate an audit. If that doesn't answer, then Jesse, I think we have to hop on a call to be able to identify it better. So sweet. So maintenance, this kind of dives into a bit of what I touched on, but maintenance is as important as new features. From documentation, bug fixing, writing new tutorials for upgrades, for introducing new users, to security and triaging bugs as they come in partnership with Amulet. But also figuring out how to get ahead of security to have preventative cases so we're not always chasing behind. And performance, we want to be able to maintain the level of performance we do have, and we also want to be able to increase it. This is continuous profiling, continuous audits of the code base, benchmarking. So this is as important for us as new features, and this is why we're kind of pointing it out in this call. I know it's not as exciting as new features and things that will come to the Cosmos SDK, but if we do want to be able to move forward, we still have to maintain where we're coming from. So the future, what does the future kind of look like? So there's a couple things that we're actually exploring. For one thing, we are looking at crossling. And so what does this mean? Being able to write modules in different languages, either via different VMs, FFI. We've been exploring a design where you have different loaders for modules. You have your native that you write modules in today, then you have FFI, WASM, gRPC. It's still very early stages. We're still very exploratory in how this would potentially work. But the long tail goal is two-pronged. First, you're writing modules in different languages, meaning that all the blockchain fanatics that love Rust can write in their favorite language without having to, at the native layer, without having to use a VM. Of course, this is like, we can still work with, we're still evaluating. And so it's like, if someone wants to, if partnering and moving closer with CosmWasm and moving CosmWasm a bit lower in the stack, making it part of like the SDK natively, then that is the direction we will go. But what does this actually mean for the current modules? Well, we want to, in the upgrade story, we want to separate what the core and the business logic are actually doing. And so we want to live in a world where the business logic can be updated more dynamically, while core can also be updated on its own, meaning that if you want to update the node binary, you can update it without having to worry if your version of the Osmosis binary can be updated, meaning that Osmosis will be worrying about their business logic, and then the node operators, the validators, would ideally be able to upgrade their binary, upgrade their node, their consensus node, without having to swap the Osmosis business logic. In a world where this can exist is a world where we can have seamless Genesis from Genesis sync. This has been a Comet touched on it. This has been a highly requested feature from teams like Celestia. I envision it as becoming more and more needed from teams that are doing types of rollups and various types of blockchains, that they want to be able to sync from Genesis, and being able to swap out different business logic or modules into different core layers, that when you're syncing from Genesis, you can sync all the way without having to swap binaries, would become a more seamless fashion than having Cosmovisor download different binaries, because then you have to maintain different binaries. And then if something happens to the P2P protocol, and then all of a sudden all these previous binaries are non-compatible, and so now you have to figure out something else. Next, this also allows us to do seamless upgrades, where all the validators, node operators, and chain devs are used to how upgrades currently work. We want to be able to fix that because we see it as cumbersome. Many validators and app chain developers are saying it's fine, we're used to it, but that is the status quo. We want to be better than the status quo, and that's why we want to be able to allow seamless upgrades. It can be similar to different fashions. It can be upgrading the binary via governance, via some sort of blob, or it can be using different module loaders. And research. So what do we want to do in the research area? Well, ZK is the hottest today. So everyone in the world of blockchain and beyond is talking about ZK. We want to do some research on how to bring ZK to the Cosmos SDK in different forms. Like it can be, we can partner with the CosmWasm team to bring into CosmWasm into different layers, validity and fraud proofs. So at validity and fraud proofs, this is needed for things like rollups, making it more efficient, and even different forms of IBC. Jehan from the Cosmos Hub has touched on how fraud proofs might be useful in the ICS world. And so there's a lot of work to be done there and a lot of research. We've been working with the Celestia team, and they have a first implementation of IAVL with fraud proofs, and we've been exploring that and upstreaming that and how to better it. And then secondly, we want to explore different VMs. So there's already a couple of VMs out there, but right now a module is very native code. You can do almost anything with it. While that's a good thing, for a lot of people, this is actually very detrimental, because this is something that it's easy to have a foot gun. And so we want to prevent these foot guns if that means bringing the modules into a more closed environment. But then that is that. But also things like we want to research into different VMs like RISC-V VMs. And there's been some interesting research there. And so just kind of like exploring the world and the direction it's going. So to close it off, from the Cosmos SDK. Just want to give a huge shout out. These are only some of the teams that are using the Cosmos SDK, but more so, these are only some of the teams that are contributing to the Cosmos SDK. Like I mentioned in the roadmap, the Cosmos SDK is not a single contributor code base. The Cosmos SDK is constantly getting contributions from everyone. We admire you guys. We are thankful for all the contributions, and we just want to see them keep coming. And so the next talk, who is going to be tying into the Cosmos SDK and kind of the Cosmos ecosystem, is CosmJS. And so Dan, if you're available.
Oh, can you guys hear me?
Yeah.
All right. Hey, everyone. Dan from Cosmology, going to talk a bit about CosmJS. I'm going to share my screen, make sure that's all working. Right. And can you guys see it? Are you guys able to see? Okay, great. So yeah, we're going to be talking about CosmJS improvements. I'll just jump right into the high level. New encoders, much more efficiency, also developer ease of use, a lot of reducing bloat, which I'll talk about, and improve maintenance, not just the maintenance itself, but like the processes and systems for maintenance and automating some of the maintenance that's currently happening, and just like a deeper integration and Telescope as a part of the effort to make it, much more reduced in size, but also improving the maintenance and all these kind of things. So I'll jump right in. One of the first things we're going to need to do, I think, with like a new feature in the SDK, I believe, is proto-visual. We had amino encoding, and then we had proto encoding. So we're kind of juggling all these different encoders. So we'll be adding into the Telescope transpiler, the proto-visual encoding when that's ready. I don't know if that one's ready yet in the SDK, but we'll obviously be syncing with you guys on that. So basically just developing the encoding, adding documentation and testing, but we'll also be continuing to support amino and proto. I figure amino will be around for a while, as well as regular proto. So we'll keep those, bug fixes and everything up to date. Also just keeping CosmJS up to date with the SDK. So as different versions roll out, just syncing with the team and making sure we have different versions. I'm also looking to exploring some kind of versioning where, if someone's using 47 or 50, we might like have a way to publish multiple versions there. But essentially just monitoring the releases and just having, collaboration, communication with the SDK team here. And this way we'll use Telescope to transpile the types and have different versions with all the modules available for CosmJS. This is more kind of generic stuff. We'll get into more details in other work items below. So we're going to update amino encoders and add modules. So currently, right now, what's happening is that all of the CosmJS amino encoders are manually coded by hand. So basically leveraging Telescope for generating the amino converters and amino encoders. And that will actually require ripping out a large amount of the code base and then creating like more of a Telescope-based workflow. We're already doing this for the proto encoders. And then we're going to also add any other necessary SDK modules. For example, I know previously like the groups module is a new one that got added in. So any modules like this will kind of add into like a CosmJS bundle that will have like kind of everything in it. I will mention that there will be a sort of the code name Simon and I are calling it right now is like a CosmJS Slim, where there will be a very lean version of the CosmJS that won't have any modules in it. And then you'll use Telescope to only transpile the modules that you want to use. So you kind of cherry pick which Cosmos SDK modules you'd like to use. And then that way you can make a very lean bundle, and we'll get more into that below because that's a really exciting area as well. So another thing is we've been getting like a lot of requests from different pub keys and networks such as like Evmos or Injective. And to avoid having a bunch of if statements inside the code, littered in a bunch of random places. We want to create like an adapter pattern. So if you guys are familiar with Cosmos Kit, we did this for wallets where, we have like, I don't know, like about 19 different wallets now. But the interface is all the same. So it's one interface, 19 different wallets. We'd like to do something similar where we can have an adapter pattern to plug in like, different key and network signing, just so that like Cosmos can play well with a lot of the other networks that we're collaborating with, such as Axeler, Evmos, Objective, where we might need to do other signing. And then this way we can give developers a cohesive experience directly from CosmJS. And those will be pluggable. They'll be separate packages. So it won't actually add bloat if you're just doing a pure, Cosmos SDK chain. If you were to use something like Evmos, we'd probably have to have like an Evmos adapter. So a point that I'd love to just focus on that I don't think has ever really been looked at for Cosmos. Well, I came from the Web 2 world, and a lot of my focus was on websites. Sites have a load time of like 1 second, have a 7% bounce rate. And it gets worse as you go higher up. And I'm not sure if you guys know this, but like if you transpile all the types for all the modules, which is the current default for CosmJS, just the types themselves are 22.8 megabytes. I have never in my career, in like 20 years, ever seen a website that was 22 megabytes. But this means any website that uses CosmJS automatically has that, in addition to everything else that they have. So we're very behind in terms of Web 2 packaging, if that makes sense. And so a big part of my goal is to kind of bring everything down to a size that's more in line with like typical websites. And so, the average page speed of a first page Google result is about 1.65 seconds. It'd be great to get to this as a goal. So some of the things that we're going to be doing surgically on CosmJS, well, one is leaner bundles and code optimization. So one of the first things you want to do is refactor the core library so that we're not going to be importing CosmJS types anymore. We're just going to use Telescope to transpile just the few types that we need. For example, like TX raw, and just, I think there's only like 3 or 4 messages that we need. The other, for staking and checking balances and all these things, we will kind of add those in. And then what we'll do is we will still maintain a version that's just like the CosmJS today that has like, staking and balances and everything is kind of bundled inside, but that will be kind of a transpiled built version with Telescope that a developer can pull off the shelf. We'll probably still name it CosmJS, but then we'll have like a CosmJS core for the advanced developers who want to have these lean bundle sizes. And they say, hey, for example, like on Osmosis, you cannot do staking, right? They direct you to Kepler. So for the Osmosis team to include the staking module actually doesn't make sense, because the way JavaScript works is it serves all the JavaScript down to the web browser of the client and has to parse through all that JavaScript before the page can do anything. So for every unutilized piece of code we send down to the client, it's still getting parsed before the user can experience the site. So we want to get to a place where apps are only sending down the code that they need. And then there's other optimizations we can do with like async important things that I didn't add to this. We can discuss if those are relevant. That's also an option too. And then that will allow for like native code splitting with like, bundlers like Webpack and Next.js, which does it by default, apparently, which is pretty great. And a leaner and extensible client for Telescope and the helpers. So some of you guys might be familiar with some of these, maybe not, but I'll just kind of go over them. So the client structure right now, we've got like a signing Stargate client, signing CosmWasm client. It's a mouthful. It's also duplicative because technically what we've done is we've just preloaded the signing Stargate client and Stargate client with all of those modules for staking and balance, et cetera, And then for the CosmWasm version, we've just preloaded that with the CosmWasm module, the prototypes and amino types, right? So technically, under the hood, they're all actually the same client. It's just that they've been pre-packaged with these types, these prototypes and amino encoders. So I think the idea is to kind of make it more simple, something like just like a signer and a client, and then having like, broadcast as a functionality in the client. We'll definitely work more closely with the teams on this API. But I think the idea is like where this shows up and is in a tool like Cosmos Kit, where our hooks now have to have like 4 different clients that we're returning. And sometimes we get a lot of questions from developers. They're like, well, when should I use the signing client versus the Stargate client? And, if you have any custom modules, which is the whole point of Cosmos, is to like customize your blockchain, then you're kind of ending up getting under the hood anyways. So the idea here is to, still provide some aliases to these during a transition version, but start shifting developers kind of understanding to kind of either having these fully preloaded clients that will provide, or the ability to, just pick and choose the modules they want, and then they'll just use a super simple client and signer. Another area of focus for making a lean version of CosmJS, we have a lot of these hard-coded helper functions. And I mean, I understand the purpose of them is for developer ease of use, and we will be addressing that as well. But they're like send tokens, withdraw rewards, send IBC tokens. The problem with these is that then the base client for CosmJS is actually now requires those types and those modules to be loaded into CosmJS itself. So again, that just removes the whole idea of the extensibility and being able to cherry pick the modules that you want. So we're going to remove all of those. And basically what this also does is it really makes CosmJS not only leaner, but more simple to maintain. So what we'll do to fix the developer experience for removing those is then make it so the Telescope has a plugin to generate helper methods for any module. So that way, like if you wanted these send tokens, withdraw rewards, send IBC tokens back, it would just be a super simple operation or option in Telescope, so you could have them back. But you could also add helpers for other things, like maybe if you're Osmosis, you would want to make one of your super simple client methods something for swap tokens, right? For a swap or something like this. So what that means is essentially instead of doing like, cosmos.bank.v1 beta 1 dot, get balance, right? You just do get balance on the core object. So that's really all those helper methods do. They're just easier access to a deeply nested module, so you don't have to know the entire path to it. And then a pipeline for signing and broadcasting. We're also going to make it like slightly easier to do signing and broadcasting. But again, in the transition phase, we want to maintain compatibility with the current API. And as usual, the flexible message type definition, leveraging Telescope. And that would be for, not only the proto, but also, as I mentioned earlier, the amino encoders. And so I think like a big part of this is really around, leveraging Telescope to automate a lot of what is being manually written by hand right now. And even to this day, the amino encoders in CosmJS are still handwritten. The proto has been fully replaced from using TS proto to Telescope. So we're in a pretty good position to do it. And then ultimately just, baking CosmJS to a much leaner core that's, just dealing with like keys and signing. And then all the customizations, like, the whole point of Cosmos, which is customizing each, chain, being able to leverage Telescope to then customize your CosmJS client to the developers, desire based off the chains that they're working with. So if there's any questions, happy to dive in there. And if there's anything I forgot to, please feel free to chime in.
Well, I would like to add a brief comment, not a question. A bunch of people might be wondering why Dan from Cosmology is talking about CosmJS. So we have been working with Confio and myself very, very closely over the last year, integrating Telescope and CosmJS. We announced a marriage almost a year ago because Telescope depends on CosmJS and CosmJS depends on Telescope. Yeah, and I'm more than happy to express my support handing over that piece of technology to Cosmology, who is really a company that is focusing on the client experience and focusing on the end user experience, something that Confio has not been able to do for a while. It did not get the attention that it deserves. And then Cosmology and the project itself has all my support in this transition for next year and beyond.
Awesome, thank you.
There's a written question for you, Dan. I'm going to murder if I try to read it. You should read it.
Is it in the chat here, or is it, sorry, is there like a Q&A? Sorry, there it is. CosmJS has never been audited. Would be good to do that. That would probably make sense. Do we have support gRPC web, gRPC gateway? Yes. Well, wait, is this Hong from Vietnam? I think, well, Telescope supports it, which Hong actually implemented. So I'm wondering if he's asking if, I'm wondering if you're answering this question more from a standpoint of like, are the chains going to implement it? Because yeah, Hong helped, he's from Notional, and we implemented gRPC web, gRPC gateway, but we have noticed that some chains aren't using it, but I'm not sure if that's where the question's coming from, since technically Telescope does already support that with CosmJS. So not sure if that answers the question, or if maybe I need another, make sure I understand where the question's coming from, since
Hong, do you want to clarify? You should
yes, I just want to ask a few questions, because I saw that Dan already mentioned about the improvement of libraries for better user experience. So I can see that in the Cosmos SDK 50, they are more focusing on gRPC. And I want to ask if CosmJS had a plan for it. That's basically the question.
For gRPC, is that the question?
Yes, because I don't see you mention about using gRPC for CosmJS.
Right.
Yeah, I think, Hong, one thing to note about that is that even in the current RPC structure, the calls mirror the format, the gRPC calls. So under the hood, switching from the existing RPC to the gRPC is a relatively straightforward operation that just requires using a different endpoint. I understand the performance implications of it. It's not a major code change and shouldn't be overly complex to support, given the structure of the gRPC requests versus the RPC requests, which is substantially the same.
Yes, it is. Like for gRPC gateway, it takes the same endpoint like the RPC gateway, RPC would do, and it gives the maximum compatibility for every client that's using it. And it's a bit harder for gRPC web because it requires another endpoint with the gRPC web endpoint. And also you have to set up the servers, otherwise it would get some Cloudflare issues, which a lot of chains had encountered before. Yeah, it's pretty straightforward. You actually just need to change the code where the client what created the code and how you encode and using it, it's not that different for gRPC gateway, I believe, and like 10% more performance. Yes.
Oh, thank you for that one. We have another question from Sardar.
Hey. So yeah, my question was that I remember one of the items was that you're gonna have a more modular integration with the Cosmos SDK modules and I guess the TypeScript client. So I guess the IBC modules are also included in that, right? So that was my question.
Oh yeah, yeah. IBC and all the base, like staking and distribution and bank modules. I think the idea would be that we're going to continue having like a version of CosmJS that's like fully loaded, and then the idea is just to give developers an option to have like a lean version where they can just add the ones in, and that way the CosmJS types library, which is around 23 megabytes, is not included. For people that really care about performance. I know the Osmosis team, that was like one of their main, one of their core concerns, which I believe is justified. And so yeah, I think the idea would be to give developers like, hey, here's how you get started. Just use like CosmJS and chain registry and Cosmos Kit, but then eventually, like once they're like, hey, now let's like fine tune this, they could use like the CosmJS core, cherry pick the modules, cherry pick their wallets, cherry pick like which chains they're working with. And so they start off with like the fully loaded version of all the core libraries, and then they eventually strip down and, get it down from like, 20 some megabytes down to hopefully like a megabyte or two. That'd be ideal.
Yeah, right. The reason why I'm asking is because we live on a separate repo. Sometimes like the new additions are not added to CosmJS. Like I think I'm not sure. I think last I checked, like the IBC fee messages still aren't there, but yeah.
Yeah, I'm also looking into different workflows for like getting the latest protos into the repositories. I've been maintaining a new one for the Interchain that's like, I'm exploring with like branches, so that if there's like a version of 47 or a version of 50, and then as like the new IBC or new CosmWasm modules come out, potentially there's a way to like keep those in sync. Also exploring the idea of using the chain registry for mapping which protos are for which versions. And if you guys have ideas for this, I'm all ears, because then you can even automate some of it.
We've done a bunch of thinking around that. I've got some ideas on that. Adding capabilities to the chain registry and linking directly to the buff repositories helps solve this problem substantially. I think partnering with the SDK team to help make that happen, we'd love to work on that too. That impacts a lot of our tooling.
Yeah, I think for us, like having some kind of a Git hash to which version of the IBC go, which version of the CosmWasm, which version of the SDK, maybe per chain could be useful, and then kind of making it required property on the chain registry or something like this. Because then we can actually theoretically build any set.
What we do have in the chain registry is the current Git repository for the chain node. And there is a Go mod file at the root of each of those repos that contains the versions for that. We can parse that out of the Go mod file fairly easily and go that direction. Yeah, I think that's totally where we want to take the chain registry.
Okay, awesome. Yeah, I love that idea, because I think like, the idea of supporting multiple versions of the SDK on the client side, I think most of the work is just the set of hashes of each of the protos. And if we can get that sorted, then we can even automate it.
Right. Just one more addition, which the idea that you mentioned is pretty good as well. Just one thing to be careful about is because there's no guarantee that whether a particular version on the main branch or a particular tag on GitHub necessarily corresponds to the live version on chain. And when you have access to to use CosmJS, you basically need to connect to a node anyway, where you can query the versions of IBC Go and SDK directly anyway. Though I know that's much harder to use to get protobufs, because you usually need protobufs before that step. But it's just something to be careful about. So it probably will need more thinking. But another thing is there were some bounce rates. Were there specifically Cosmos websites, or just a Web2 websites that you were showing after 2 seconds, this is the bounce rate?
For the client-side tooling, Cosmology, we have quite a few tools on our GitHub. Other than that, I think it's just CosmJS. So, CosmJS for, signing and broadcasting. Cosmos Kit is what we built for connecting to all the different wallets. And then, Telescope and TS Cogen, those are for transpiling the SDK modules and smart contracts. So those are on Cosmology's GitHub there.
Yeah, sorry, I think I talked about two different things back to back, and I wasn't very clear, and I'm sorry about that. I was just talking about you had a presentation there. There was a chart of when users when the website takes 1 second to load, this is how many users leave the website. When it takes 2 seconds, this is how many. I'm just asking, where did you get that data? Is that data for dApps, or is that data for general websites?
Oh yeah, this is just general website information. If you do some Google searches on SEO and website performance, you'll find a whole plethora of information around this. But generally, if you have too large of a website, you'll lose users within the first few seconds.
What I saw there, yeah, the reason I ask is because I think weirdly, I don't know how this happened, but 1 second had higher bounce rate than 2 seconds, and then the rest was normal. So it was if your website loads in 2 seconds, it's better than it loading 1 second.
Wow. Yeah, I should check that. That's interesting. It's almost like they expect it to be a little slow. It's too fast. Wait, there's nothing here.
One other quick comment on the discovery of different chains protobuf files. There is an endpoint that protobuf exposes where you can pull the proto files for the entire chain directly from the chain itself. I think this is the proto introspection work. There was a lot of work in Go to wire that up such that you could have auto-generated clients, and I think auto CLI helps do this partially. Maybe there's some work there that could be ported into JavaScript too.
Dynamic server reflection is what they kind of call it in gRPC land. We're using it quite heavily for things like auto CLI. But yeah, we can talk about that, Dan.
Cool.
Time.
Yeah, sounds great. Yeah, if we do that one, it'll just make it super easy. If a new chain needs a library, they could probably just click a button or run one command. So that'd be nice for any version.
Yeah, that's where we need the tooling to be.
Dan, I think there's another comment/question for you in the Q&A about multi-version support.
Okay. So I believe I want to make sure I understand this one. So we're talking about there's different ways of supporting multiple chains here. This could be what I believe is needed for indexers, wallets, and maybe block explorers, if I understand it correctly. Meaning that you want to have a site that can load multiple versions of chains at the same time. Not necessarily having different libraries for each chain. We have explored this a bit. We were thinking about making this multiplexer plugin where basically for example, for let's say the Mint module, you might have a different, I think Juno has a different Mint module than the SDK, for example. So there could be a way to kind of abstract out similar to the adapter pattern, but it would kind of okay, for Juno, we use this one. For normal, typical SDK modules, we use this one. And it'll be a switch statement and kind of call these different modules. We've actually prototyped this with PingPub, because PingPub actually does this quite a bit. hard coding it in his code base. It's not like an easy task, but the idea is then to parse multiple versions of protos across different versions, but then still kind of access them from like one library. I believe this is what you're talking about. The current way to do this is just to generate like 2 different libraries. Or you can kind of go in and potentially like hard code some stuff the way that PingPub has done. But we are exploring like a multiplexer plugin for Telescope. That could definitely be something that we do next year for sure. It's definitely like it's been on our roadmap and on our minds for a while.
Yeah, just wanted to say that generating multiple versions of the libraries wouldn't be the perfect solution for tools and sites which need to operate with multiple chains. So yeah, that's exactly what I was commenting on. Check out also Gino, like this, JavaScript, like this new JavaScript runtime. They also have some good ideas how to deal with different versions, and like this way you could basically do some different imports based on the version, and maybe that would help.
I think the discussion around the proto reflection stuff also really bears on this too, because if you can automatically detect the version from the server itself and then have the right bindings, the library can take care of all of this. So yeah.
Yep. I also note that like I have thought quite a bit about this too, and generally the users that need this feature are like indexers, wallets, block explorers. And so like, it hasn't been prioritized as highly as just like the typical dev who's building on a chain. Maybe if maybe we could also get some input from some of those folks, like maybe, Mintscan or, PingPub, and kind of get together to like how they've solved some of these problems, because they definitely have. And not sure if it's the best solution, but maybe getting some ideas and feedback from those guys as well before kind of embarking on building something ourselves.
Yeah, I just in the chat, like putting the comment about the Dean.
Any other questions for any part of the stack? Deafening silence. If there's no other questions, I'm going to pass it on to Maria, the managing director here at the ICEA, to close out this call.
Yeah, thank you, Said, and thank you, everybody. Thanks to the dev teams for all the presentations and for all your hard work. I think this is a very important step in the history of the Interchain stack, that we're having these roadmaps now. I hope that and thanks also to the attendees for joining today for 2 hours. Most of the people that stayed during the whole 2 hours. That's great. That shows engagement. I hope that the call has been helpful for everybody, and it acts as a starting point, or open up the discussion around these roadmaps. The dev teams, they do have monthly community calls. We are going to put that information together and send to everybody that information of when and how those calls happen. So this discussion continues during those calls. Keep also sending feedback. As I said, we are going to have this first window of feedback that ends up in September the 30th. And the idea is that to give the community of builders and users of the stack, the community of potential dev, developers for the Interchain Stack and the broader community an opportunity to give feedback on these roadmaps and have that first interaction of the roadmaps that we are going to use in order to make a decision in terms of the resource allocation for 2024. So yeah, that's it. Thank you very much, everybody.
All right. Thank you, everyone. Take care.
Thanks to the ICF for facilitating this.
Thanks very much, everyone.
Thank you.
Thank you.